Welcome all. Myself Vinayak Kulkarni from Walchand Institute of Technology, Solapur. So today's topic for the session is priority scheduling. Let's proceed with the topic. So first of all, we will understand what is the learning outcome of the session. At the end of this session, students will be able to solve problems on priority scheduling. Introduction. CPU scheduling is a basis of multi-program operating systems. By switching the CPU among the processes, the operating system can make the computer more productive. So what is the use of CPU scheduling? Rather than executing a single process, we are going to execute multiple processes on CPU. So there are basically two types of process scheduling. One is primitive scheduling, another is non-primitive scheduling. So what is mean of primitive scheduling? In case of primitive scheduling, if a higher priority process or if the arrival time of the process, so based on these 2 points we can preempt currently executing process. In case of non-primitive scheduling, we are not going to preempt any process will execute completely till it gets completely executed. So these are the two basic types of scheduling, primitive scheduling and non-primitive scheduling. So priority scheduling. So what is the meaning of the word priority? A priority is associated with each process and the CPU is allocated to the process with the highest priority. So what is a priority? Priority is a number and we are going to assign, or CPU is going to assign a number to that particular process. And the process having highest priority will be executed first. And if the two processes are having equal priority, then processes are scheduled in a FCFS order, first come first served order. Priorities are generally indicated by some fixed range of numbers. Low numbers represent higher priority. So it means that if we have a process P1, P2 and P3, and if the priority for P1 is 1, P2 is 2, P3 is 3, then higher priority is of P1. Lower number represents higher priority. Priorities can be defined either internally or externally. Priority scheduling can be either primitive or non-primitive. When a process arrives at the ready queue, its priority is compared with the priority of the currently running process. So when process arrives at ready queue, we are going to compare the priority of currently executing process. In case of primitive priority scheduling algorithm, process will be preempted if the priority of the newly arrived process is higher than the priority of the currently running process. In case of non-primitive process scheduling, we simply put the new process at the head of the ready queue. So in case of non-primitive priority scheduling, the process is not preempted. Based on the priority, the process is completely executed one by one. Let's see the problem on priority scheduling. The given data is 5 processes are given P1, P2, P3, P4, P5. Arrival time is given as 0. So in this case, we are not considering arrival time. Arrival time is given as 0. Burst time is given and priority is given. So observe that P1 priority is 3, P2 priority is 1, P3 is 4, P4 is 5, P5 is 2. So from this, in case of priority scheduling, the order of execution of a process depends upon the priority. So in this case, the P2 is having priority 1, so P2 is having highest priority, P2 will execute first, after that P5, after that P1, after that P3 and P4. So this will be the order of execution. So in case of scheduling algorithms, we show the concept of execution of each process by using a chart called as Gantt chart. So what a Gantt chart shows? It shows the process execution with respect to the burst time. So in this case, P2 is having higher priority. So P2 starts execution first. P2 is having the burst time only 1 millisecond. So P2 is going to execute between 0 and 1. After that, P5 executes between 1 and 6 because P5 is having the next priority. P1 executes between 6 and 16 because P1 is having the next highest priority. P3 and P4. So in this case, P2 will be the first process because it is having highest priority. P4 is the last one to execute because P4 is having a lower priority. Next thing is, these are the two formulas required to calculate. First is turnaround time, waiting time. So in this case, we have to calculate completion time, turnaround time and waiting time. Okay, so next thing, to calculate turnaround time, we need completion time minus arrival time. To calculate waiting time, we need turnaround time minus burst time. So you can remember these formulas, it can be used to solve the problem. First of all, let's calculate the completion time from the Gantt chart. So observe that P2 completes at 1 millisecond. So completion time of P2 is 1. P5 completes at 6 milliseconds. P5 completion time is 6 milliseconds. P1 completes at 16 milliseconds. So P1 completion time is 16. P3 completes at 18 milliseconds. P3 completion time is 18. P4 completion time is 19 milliseconds. So from the Gantt chart, you can easily calculate the completion time. Let's go to the calculation of turnaround time and waiting time. So observe that this will be the final expected output in case of the problem. First column is process, second column is arrival time, third column is burst time and the fourth column is priority. All this is given data. From the Gantt chart already we have calculated completion time. Let's calculate turnaround time. So what is turnaround time? It is completion time minus arrival time. So observe that P1 turnaround time 16, P2 1, P3 18, P4 19, P5 6. After that we calculate waiting time. Waiting time is turnaround time minus burst time. So from this you will get P1 burst waiting time 6 milliseconds, P2 0 milliseconds, P3 16 milliseconds, P4 18 milliseconds, P5 1 millisecond. Let's calculate average waiting time and average turnaround time. So in this case, average waiting time is 8.2 milliseconds, average turnaround time is 12 milliseconds. If we compare this time with the FCFS, then priority scheduling will be the best suitable over the FCFS. Issues with the priority scheduling algorithm. So major problem with priority scheduling algorithm is indefinite blocking or starvation. It means that some process or a low priority process will wait for indefinite amount of time. That process is not able to execute. That is the meaning of indefinite blocking or starvation. So this will be the main major issue faced with the priority scheduling algorithm. Next is think and write. Just pause the video and try to find the answer of the question. A solution to the problem on indefinite blockage of low priority process is called as. Let's wait for some time and try to find the answer. Hope you have solved. A solution to the problem on indefinite blockage of a low priority process is solved by using the concept of aging. What is the meaning of aging? Aging is a technique of gradually increasing the priority of a processes that wait in a system for a long time. So what is use of this? If a process is having low priority and it is going to wait for a long amount of time, then the priority of that process will be increased gradually, so that in future that process will get a CPU for execution. References. Thank you.